Hello students, Miss Swanson here, and today we're learning all about significant digits. Now, I have a little comic here. I'm not going to explain this one now, but I ask you at the end of the video to come back to this and read the comic and see if it makes sense to you. I think you're going to laugh. It's really cute. So what are our learning goals today? Well, we have one. To identify the number of significant digits that are in a number. Now we have a whole series of rules. You'll be learning the rules right now. They can get a little bit complicated, so if you're having trouble, make sure that you ask me in class tomorrow. So first of all, before we can get into those rules, we need to know a little bit of terminology, the difference between exact values and measurements. So exact values are either defined quantities, so something like a kilometer equals 1,000 meters, so that's an exact value, or something that's counted, like there are 5 beakers there, or there are 10 cells that I can see under the microscope. So things that are counted or things that are defined values are considered exact. And they are considered to be certain with no error. Measurements, on the other hand, are anything that we measure in the lab, like time or temperature, mass, and so on. And these are considered uncertain, so they have a little bit of error in them. It's because of this error that we need to use significant digits or significant figures, because this tells us how much or how accurate our measurements actually are. So significant digits are significant figures. These are the digits in the number that you actually know to be true. So a speedometer, let's say you're driving and it reads 62 kilometers per hour. Well, this might be 62.3889 kilometers per hour, or it could be 61.8937 kilometers per hour. We don't know that specifically how fast you're going. You only know that you're going 62 kilometers per hour. So we only know the value to 2 significant digits. We don't have any more information than that. So if we look at exact values, these have an infinite number of significant digits. So something like 365 days in a year, we know that's true. You can almost consider it as 365.00000 off to infinity, and they're an infinite number of significant digits. So with our exact values, when we're doing calculations, they are never the limiting quantity to figure out how many significant digits are in our answer. So it's always the uncertain values that determine our least number of significant digits. Measured values, on the other hand, depending on the actual number, have different amounts of significant digits. So we have a set of rules for this. All non-zero digits are significant. So if it's not a 0, then you can count it as a significant digit. So 7.2 has 2 significant digits. Zeros between non-zero digits are significant. So 105 has 3 significant digits. We include the 0 because it's between a 1 and a 5, and those are both non-zero digits. Zeros to the right of a decimal point are considered significant. So 1.000 has 4 significant digits. So we can't just write zeros at the end of a decimal willy-nilly. We can only write them there if we actually know them to be significant. Placeholder zeros are not significant. So placeholder 0 would be something like this, 0.004. The only significant digit is the non-zero digit 4. So there's 1 significant digit. Those other zeros are just holding the place, so we know that it's not 4, it's not 0.4, but it's 0.004. Final zeros that come at the end of the number, if they're written in standard notation, they're ambiguous. That means we don't know if they're significant or not. And this is one of the drawbacks of standard notation. So if we had 128,000, there could be 6 significant digits or 3. We don't actually know based on the number being written in that way. Now when we're doing calculations, we always assume the least number. So there could actually be 6 significant digits, but we would have to assume that there are only 3 because we don't have any information to tell us that there are in fact 6. So this is one of the reasons that scientific notation is very useful. Final zeros in numbers written in scientific notation are significant. So if we are given 1.28 times 10 to the 5, then there are 3 significant digits. But if it was 1.28000 times 10 to the 5, we know there are 6 significant digits. So it's the same number but with different number of significant digits, and when it's written in scientific notation, we actually know that information. So let's look at our learning goal. Can you identify the number of significant digits in a number? If you can, fantastic. If not, please rewatch the video, and if you're still having trouble, come ask me in class tomorrow. Alright, that's all for now. Bye-bye.